Hello ladies and gentlemen, welcome to my video. For today's question, we can solve it using integration by part. Along the way, we need to use L'Hopital rules and some algebra trick as well. But first, label the question Q as equation 1 and then apply our usual trick. Change the x become 1 over x. Therefore, dx become negative 1 over x squared dx. For the integration bound, infinity change to 1 over infinity, which is 0, and 0 change to 1 over 0, which is infinity. Therefore, q become integral infinity to 0, natural log of 1 over x, divide by 1 over x power 2 plus 1, and then the whole thing power 2, multiply negative 1 over x squared dx. Here we include multiply x power 2 to both numerator and denominator. Q become integral 0 to infinity negative x squared multiply natural log x, and then divide by 1 plus x squared, and then power 2 multiply dx, label it as equation 2. Now we do another usual trick. Sum out equation 1 and 2. Give us 2q equals to integral 0 to infinity 1 minus x squared multiply natural log x, divide by x squared plus 1, and then power 2 dx. This can be solved by integration by part, so it is equals to integral u multiply dv, where u is equals to natural log x. Therefore, du equals to 1 over x dx. Meanwhile, dv equals to 1 minus x squared, and then divide by x squared plus 1 multiply dx, which means v is antiderivative of dv. Now, look at the integrand here. It can be rewrite become 1 minus x squared, and then divide by x, and then multiply x plus x power negative 1, the whole denominator power 2, which is equals to x power negative 2 minus 1 divided by x plus x power negative 1, and then power 2, which is can be further rewrite as negative 1 minus x power negative 2 divided by x plus x power negative 1 power 2, which is equals to the differentiate of 1 divided by x plus x power negative 1. Put it back to here. Obviously, v is equals to 1 divided by x plus x power negative 1. So now we have v, we have u, and we have du. That is good enough for us to do integration by part. We have 2q equals to uv minus integral 0 to infinity v du, which is equals to natural log x divided by x plus x power negative 1 and the respective limits. Then minus integral 0 to infinity 1 divided by x plus x power negative 1 multiply dx over x. For now, we focus on the first part, which is L equals to L infinity minus L0, where L infinity is equals to limits x tends to infinity natural log x divided by x plus x power negative 1, which is equals to infinity divided by infinity. We can apply L'Hopital rules. Becomes limits x tends to infinity 1 over x divided by 1 minus 1 over x squared, which can be simplified become x divided by x squared minus 1 equals to infinity divided by infinity. Apply L'Hopital rules again. The top become 1 while the bottom become 2x minus 1, which is 1 over infinity. So therefore L infinity equals to 0. On the other hand, L0 equals to limits x tends to 0 natural log x divided by x plus x power negative 1, which is equals to negative infinity over infinity. Apply L'Hopital rules. We can use the one that previously we derived, which is x divided by x squared minus 1 equals to 0 divided by negative 1. That gives us L0 equals to 0. Go back to the previous equation. The first part of 2q is equal to 0. Therefore, it is only depending to the second part. Let's copy the equation for 2q over here. Q equals to negative 1 over 2 integral 0 to infinity 1 over x squared plus 1 dx, which is equals to negative 1 over 2 multiply inverse tangent x for x equal to 0 and infinity. Now we know inverse tangent infinity is pi over 2 and inverse tangent 0 equals to 0. That brings us to the conclusion of this video. The final answer of this question is negative pi over 4. Thank you for watching this video until the end. Please continue support my channel. Subscribe, give a like and share my video with others. See you soon for my next video. Bye bye.